Hello everyone. I would like to introduce myself before I proceed our topic today. So I am Joy Melodies Magaitera from BSBA 2, the subject of GE10 Environmental Science, Section O. Our topic today is all about types of energy and law of thermodynamics. What is energy? Energy is defined as the ability to do work. Energy comes in many different types, which can be categorized into two basic forms, kinetic energy and potential energy. There are many different types of energy, which are chemical energy, gravitational energy, electrical energy, nuclear energy, thermal energy, motion energies, sound energy, gravitational energy, and so on. Energy can never be created or destroyed, but it can be transformed from one type of energy to another energy. Kinetic energy. Kinetic energy is energy in motion or the energy of moving an object. It is also a form of energy that an object or a particle has by reason of its motion. The energy that an object has due to its kinetic energy. Ito ay tinutukoy bilang ang dami ng pagsisikap na kailangan upang mapabilis ang isang katawan ng isang naibigay na, mula sa paghinga hanggang sa isang tinukoy na bilis. For example, in this picture, that it has energy to perform the object. Potential energy. Potential energy is the energy held by an object because it is positioned relative to another object, traceless within itself, its electric charge or other factor. Potential energy, a type of stored energy that is determined by the relative position of the various components in a system. Like for example, that it has a potential energy because the object possesses gravitational potential energy because it is positioned at the height above the zero height. So in this picture, we can see in this picture that na ang boy ay hinahawakan ng bola, steady ang bola, so that is a potential energy. Kapag binitawan niya ang bola, the potential energy transforms into the kinetic energy. Mechanical energy. Mechanical energy is the sum of the kinetic and potential energy of a system. It is the energy resulting from the movement or physical location of an object. Either the kinetic or potential energy may be zero at any time at the given time. So this is the picture that a car driving up and down a hills has both kinetic and potential energy. The car gains potential energy as it nears the top of the hills. Unless the brake are applied, it gains kinetic energy as it goes down the hills. Last, nuclear energy. Nuclear energy is the energy of the atomic nucleus. It may be released by nuclear reaction or the other changes in the nucleus. So this is the picture of nuclear energy.
Hi guys, I am Daisy Piranha and I will be discussing the continuation of the report of Jolie May, which is the types of energy. So I have here ionization energy. So ionization energy, just as the atomic nucleus has energy, so the electrons orbiting the nucleus. Ionization energy is the energy that binds electrons to a molecule, atom, or ion. Ionization is a process by which ions are formed by gain or loss of an electron from an atom or molecule. When an atom gains an electron, energy is usually released. This energy is called the electron affinity of that atomic species. While in losing of electron in an atom, it requires energy input. The energy needed to remove an electron from a neutral atom is the ionization energy of that atom. It is easier to remove electrons from atoms with a small ionization energy, so they will form cations more often in chemical reactions. So in this picture, it is an ionization process where an electron is removed from an atom. Next is the chemical energy. So chemical energy is released or absorbed by chemical reactions between atoms and molecules. So a chemical energy may be released during a chemical reaction and mostly produces heat as byproduct known as an exothermic reaction. The example of stored chemical energy are batteries, coal, wood, natural gas, and cellular respirations. Mostly, when the chemical energy is released from a substance, it is transformed into a new substance, like the coal and the wood. The chemical energy of the coal and the wood will be converted into light and heat. Another is the batteries. The batteries will generate electrical energy from a chemical reaction. But in order to release the chemical energy, it needs a chemical reactions in the form of heat. So these are the examples of chemical reaction, of chemical energy. The potassium react with water, burning matchstick, burning wood, burning candle, burning natural gas, combustion of coal, dry cell, and respiration. Electromagnetic energy. Electromagnetic energy is also called radiant energy. It is energy from light, magnetism, or electromagnetic radiation. It is a form of energy that is reflected or emitted from objects in the form of electrical and magnetic waves that can travel through space. So, electromagnetic energy is a flow of energy at the universal speed of light through free space or through a material medium in the form of electromagnetic waves such as radio waves, visible light, and gamma rays. Thermal energy. Thermal energy is an energy associated with heat. It is a type of electromagnetic energy. Thermal energy reflects the temperature difference between two systems. So thermal energy possessed within the object or system due to movement of the particles within the object or system. Example is a heated element on a stove contains thermal energy, and the more you turn up the stove, the more energy the stove contains. This thermal energy is the movement of the molecules that make up the metal of the stove element. We all know that we can see the molecules moving, but they are. The faster the molecules, the more internal thermal energy they contain. So, another is, if we will put a pot of water in the top of the heated element, which is the stove, so the stove will work. Work is referring to the movement of something when a force is applied. So, if we will put a pot of water in the heated stove, the thermal energy of the stove will transfer to the pot and ultimately to the water. So, this transfer of thermal energy from the stove to the pot and to the water is referred to as heat. So, in this picture, we can see the heated stove and the pot being put. Sonic energy. Sonic energy is an energy associated with sound waves. Sound waves travel through air or any other medium. So, sonic energy is produced when an object vibrates, which results in noise. The sound vibrations cause waves of pressure that travel through a medium such as air, water, wood, or metal. Or in short, sonic energy is sound waves. Sound is vibration. The movement caused by sound waves is a type of kinetic energy. Example is the vibration of the guitar string, or our voice, or a song. The last type of energy is the gravitational energy. Gravitational energy is the attractive energy between objects based on their mass. Often, it serves as a basis for mechanical energy, as objects have potential energy with respect to one another and may move closer to each other. When something has a higher position, its gravitational potential energy is high. For example, a book on a high bookshelf has higher potential energy than a book on the bottom shelf because it has farther to fall. Another examples are the skiers on a ramp at a height. A stone placed at a height drives the nail farther in a block if dropped, and the weight hanging at a height from the crane.
Good day, everyone. I am Reina C. Pulmentera, the third reporter of Group 2.
The topic that I will be going to discuss is all about the law of thermodynamics. But before we start to tackle about the law of thermodynamics, let's first tackle what thermodynamics is. Thermodynamics is a branch of physical science that treats various phenomena of energy and the related properties of matter, especially of the laws of transformation of heat into other forms of energy. Pretty confusing, right? Now, let's make it simple for you. But first, let's recall what entropy is. So, entropy is a measure of disorder and randomness of a system. For better illustration, take for example, if the bottle of carbonated drink, when you shake it, you can see bubbles forming at the top surface, and when you open it, the bottle of soda explodes and forms a lot of bubbles. This is entropy. So now, let's proceed to the first law of thermodynamics, which is the zeroth law of thermodynamics. Zeroth law of thermodynamics actually gives us an idea about heat and energy. It says that zeroth law of thermodynamics refers if two systems are in a thermodynamics equilibrium with a third. Therefore, they are in thermodynamics with each other. Or in a simple word, when two bodies contain a two different heat energy come into contact, then that heat follows from hotter to colder until both phases have equal energy. So, here's an example. as you can see, there's an system A, B, and C. That is, if system A and C have the same internal energy and system B and C the same internal energy, therefore, they have the same relation with each other. Then, this system A and B would also have the same relation with each other. So, na ako equation dira nga gibutang A is equal to B and B is equal to C, then A is equal to C. Ayaw mo kalibog ana kay kuha na siya kanang same ra na sila. Mura bag congruent ana na siya, guys. Let's proceed to first law of thermodynamics. So the first law is known as conservation of energy. This is where heat is converted to work and work is converted to heat. This is a figure that shows the process of the first law. So as you can see, in the state 1 is where the heat is stored, and in the state 2, this is a system where the heat transferred. Therefore, the heat transferred into the system and work done by the system where it transferred. In short, energy in conserved to its form can be converted. So, on the first law of thermodynamics, there's an equation for that, which is delta U is equal to Q minus W, where delta U is a change of internal energy, and Q is the net heat transfer, or the sum of all heat transfer into and out of the system. And last is W, is a net work done, or the sum of all work done on or by the system. Let's proceed to the next law, which is the second law of thermodynamics. Second law of thermodynamics is a fundamental law of nature which explains that heat can only flow from hot body to cold body by itself. So, just like a coffee in a cup, sa una nimong ibutang, init pa na siya, imong butang init pa na siya, then after few minutes, mo cold na siya. More example is our age. Kuan, gikan tag bata, then magkagulang ta, dili na siya mo balik og pagkabata, kundili magpataas na siya sige. Muna siya gipasabot sa second law of thermodynamics. And the last law of thermodynamics is the third law of thermodynamics. So, third law of thermodynamics states that as temperature approaches absolute zero, the entropy of a system approaches a constant minimum. Here is the example of third law of thermodynamics. As you can see in the first picture, na nakabutang dira sa taas o nga decrease in temperature. So, mo decrease ang iyang temperature, mo decrease pod ang iyang kinetic energy. Dahil kung mo decrease pag yun og minaayo yung temperature, mo decrease pod og minaayo yung kinetic energy. Then kanang naa sa right side kanang magtan-aw mo sa akong presentation, anay nakabutang na 0 Kelvin or negative 273.15 degrees Celsius, muna siya ay zero kinetic energy. So, in third law of thermodynamics, we have an equation for that. Q is equal to mc delta T, where Q is energy lost or gain, M is mass, C is specific heat capacity, and delta T is a change in temperature.
And that's all, and I hope you learned something from us today. Once again, this is Group 2 reporters, and have a nice day.